Okay, this is the last part of the notes for this day. We are going to identify transformations that change the graph from the pre-image to the image. So if we remember some of our prefixes and suffixes, excuse me, that you learned in English, we know that the pre for prefix is before, and then this is going to be after. So we want to know how we go from the pre-image to the image. So the transformations that change one to the other. Okay, so the order that I always want to do this in is if there is a reflection, we do that first. Okay, and how do I know if there's a reflection? So when I ask questions like that, try to answer those in your head. So this is my before, and then I have my after. So the before on the right, after on the left. So we notice that they are both opening up, so there is no reflection. Okay? Now, after I talk about the reflection, it doesn't matter what order you do everything in. Okay? Now we have to look for, is there a vertical stretch or shrink? Okay, so vertical stretch and shrink all have to do with slope. Okay, so I need to look at the slope and see if they are different. If they are different, then I will have a vertical stretch or shrink. Okay, so I'm going to look on the same side of each one. So I'm just going to go from, here's my vertex on the before. Make sure you're careful with the scale here. So I want to go, if I go up 1, that's up there, and over 1. So I go up 1, over 1, that means that I have a slope of 1. You could also use your slope formula if you would prefer. Okay, now if I go to this other one, if I go up, let's see, this is over 1. So if I go up 2 over 1, so I go up 2 over 1, my slope is now 2. Okay, so I started with a slope of 1, and now my slope is 2. So I need to figure out what changed. How do I go from one to the other? Well, when we think about a stretch or a shrink, that means that we're multiplying the slope by a certain number. So when I said vertical stretch of 3, that means instead of the slope being 1, it's now 3, because 1 times 3 is 3. It's multiplied by a 3. Okay, so my slope was 1, now it's 2. So to go from 1 to 2, I need to multiply 1 by 2. So my stretch, so my I'm multiplying by 2. So since that number is bigger than 1, it's going to be a stretch. So I have a vertical stretch of 2. Because I'm changing my slope from 1 to 2. If I were to reverse the order, so if I went from 2 to 1, so if I was going from 2 to 1, what would I multiply to get to 1? So 2 times what gives me 1? Well, think about it as dividing. If I take 2 divided by 2, I get 1. So I'm multiplying by a half. Now, since that number is less than 1, I would have a vertical shrink because it's getting wider. This one's a little bit hard to tell because the pre-image is you don't see very much of the graph, but you notice that the graph gets narrower. That means there's been a stretch. Okay, it's narrower, so it's got a vertical stretch of 2. Then the second thing we have is a translation. Okay, so I am moving from this vertex over here to this vertex. So all of my points are moving the same amount. So it doesn't matter whether you say left or right or up or down first. So if I'm starting here, you have to start at the pre-image. I'm going to go down, and then I'm going to go to the left. Now I need to figure out how much it is. So I go 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to go down 7. And I'm going to go 1, 2, 3, 4, 5, 6. Left 6. So my answer is that. That's how I go from the pre-image to the image. Okay, so now that I've done one with you, make sure you try this one first, okay? See where you get stuck. Okay, so now let's go over it. So remember that I said you always have to do the reflection first, okay? Now, when I look at this graph, one of them is opening up, the other is opening down. So I have to do the reflection, okay? Now, this is where it's important, okay? If you say reflect over the x-axis, that's my x-axis. A reflection over the x-axis, this is already up. So to reflect it, it's going to have to go down to there, okay? That's where the vertex would be, and then it's reflected. Notice that since the vertex has moved, that is going to affect my translation. That's why we have to do it first. If you tell me to translate to there, and you say that before you say the reflection, then when you say reflect over the x-axis, now your vertex is moving. And that's not where we want it to be. So the order that you tell me matters, okay? Now there are other options for what we're going to reflect over, okay? So you don't always have to reflect over the x-axis. If you want to keep it consistent, go ahead and do that. But you have to keep track of where the vertex is going to move. The other option is that you could reflect, so when it was the parent function, it was on the x-axis. So that's why the vertex didn't move. So we could also we can reflect over any line, if you remember in geometry. So if we want it to be on the line of our reflection so that the vertex doesn't move, then I have to reflect over a different line. So the equation of this line is y equals 1. It's a horizontal line, goes through y equals 1. Okay, so if I reflect over the line y equals 1, then when I reflect, it does not change where my vertex is, and my translations are the same. Okay, so there are more than one correct answer here. I will write down one of them, but kind of talk through the other one. Okay, so our reflection over y equals 1 does not move the vertex, so our translations stay the same. Okay. If you reflect over the x-axis, your translations will be different numbers. All right, keep that in mind. So let's look at the next thing we usually do is vertical stretch or shrink. So I want to look at my slope. So I go up 1 over 1. So my slope is 1. And over here on my image, I go down 2 over 1. So my slope is, well, that would be -2, but if we just think of it, either side, slope is 2. So if you're looking at this side, it'd be +2. If you're looking at this side, it's -2. Okay, so our slope is 2. That's what we have to look at. So first thing we do is reflect over y equals 1. Second thing, we have a vertical. Now is it stretch or shrink? So I'm going from 1 to 2. So it's getting narrower. So we're going to have a stretch of 2. 1 times 2 is 2. If that's something that's hard to understand, just ask me. I will explain it again to you, okay? And then we're going to look at our translation. So we reflected over y equals 1. Okay, it's opening down now. But it doesn't move the vertex, so I'm going to just count. So I have 1, 2, 3. So down 3. And right 1, 2, 3, 4. Okay, if you reflected over the x-axis, your stretch would still be there. That part would be the same. But the translation, when we reflect over the x-axis, now my vertex would be down here. So I would only be translating down 1, but still right 4. Okay, so this changes if I'm changing and reflecting over the x-axis. I know that that can get confusing, so just remember that if the vertex is not on the x-axis already, okay, it's going to move. It's going to change location if you reflect over the x-axis. So to keep it from moving, you can reflect over the line that goes through the vertex, the y-coordinate of the vertex. Okay, let me know if you have any questions. Feel free to go back and watch the videos over and over again. All right, bye.